Alright, we have a probability distribution problem here, and the problem reads, a manufacturer calculates that the lifetime of his laptop batteries is normally distributed with a mean life of 28 months and a standard deviation of 7.5 months. The manufacturer gives a 12-month guarantee on each battery. What is the probability that a battery will last more than 38 months? Alright, so we are given that the problem is normally distributed, which means that it will have a bell-shaped curve, which is what we have down here on the bottom. This is a picture of a bell-shaped curve, and the average lifetime of the battery will be at the direct center of the bell-shaped curve. So we're given that the mean life is 28 months, so mu equals 28 months, and the standard deviation is 7.5 months. So sigma equals 7.5 months. And down on the bottom here, to show it on the graph, mu is at the direct center, that is our average. We're saying that 50% of the batteries will last greater than 28 months, and 50% of the batteries will last less than 28 months. So here's our average. And we'll say that this line over to the right, that this one represents 38 months, which is the specific probability that we're trying to find. And in this problem, what we're really trying to find is the area over to the right of this line that represents 38. And we know that the total area underneath this bell-shaped curve is 1, because the probability will always land between 0 and 1. And you can't have greater than 100% probability of something happening. So in order to find the area over to the left of the line representing 38, we can use Excel with the equation equals norm dist of, and we give our x value, which is 38 months, our mean, which is 28 months, our standard deviation, which is 7.5 months, and true. And as I said, this will give the area that is to the left of the line that represents 38, and that is 0.909. Now, in order to find the area that's to the right of the line that represents 38, we can take the total area, which is 1, minus the area to the left, which is 0.909. Actually, we'll do 9088. And that will give us the probability to the right of the line that represents 38, which is 0.0912. So the probability that x is greater than or equal to 38 months is 0.0912. And to interpret this number, what we're really saying is that 9.12% of the batteries will last longer than 38 months. So if we were to take a random sampling of these batteries from this certain manufacturer, we would find that 9 out of every 100 batteries would last longer than 38 months. Now, when we're given a problem like this, and they give us a standard deviation and tell us that it's normally distributed, we can apply the empirical rule to it, which says that 68% of the data will be within 1 standard deviation of the mean, and 95% of the data will be within 2 standard deviations of the mean. And if we scroll down here to this picture, it shows what I'm talking about. So we see that the mean is right here in the center, which was our 28 months, and the number that we were given, 38 months, is within 2 standard deviations of the mean, which is right about there. And what the equation in Excel is doing is it's using this empirical rule and the standard deviation that we put into it and the mean that we put into it to find out what the exact percentage is. So if we put 38 right here, we can then look at this chart and estimate that the probability that a battery will last longer than 38 months is going to be less than 16%, because we're adding 13.5% and 2%. So we can get an approximation, and then when we put it into Excel, it will give us the exact number, which as we saw earlier was 9%.